Hi guys, maayong adlaw. Welcome to NatzMath TV. For today's video, I will be presenting to you about the truth values for conditional and biconditional statement. This is now the second part of the two-part series for this topic about truth values. In my first video, I had presented to you about the truth value for conjunction and disjunction. For this video, we will be discussing about the truth values of conditional and biconditional statements. So to proceed, let us go directly to the truth table for conditional and biconditional statement. Simple for conditional statement is this arrow. That means P implies Q. We have here the hypothesis and conclusion. This is also called the if-then statement. So we have four possibilities for our statements P and Q. Then we have here the compound statement P implies Q. If the first statement or the P is true and the Q is true, our compound statement P implies Q is also true. Now, the second possibility, if the P is true but the Q is false, our compound statement P implies Q is false. Then the third one, if the P is false and the Q is true, then the compound statement is true. Now, if both P and Q are false, then our P implies Q is true. Now, as you have observed in this truth table, for conditional statement, our compound statement can only be false if the P is true and the Q is false. Other than that, the conditional statement is a true statement. Now, let's proceed to the truth table for a biconditional statement. We use this symbol, a double-headed arrow. That means P if and only if Q. So we still have two variables for different possibilities. For biconditional statement, if both P and Q are true, our compound statement is false. But if either of the P and Q are true, either, not both, meaning the compound statement is true. So if the P is true and the Q is false, the compound statement is true. If the P is false and the Q is true, our compound statement is true. If both P and Q are false, then our compound statement is false. So we have if both P and Q are true and if both P and Q are false, the compound statement is false. Now let's proceed to the negation. Of course, the same, we have both statements P and Q, the negation of P and the negation of Q. If the P is true, the negation of that is false, and if the P is false, the negation of that is true. And for Q, the negation of false, of course, is true, and the negation of true is false. Okay, let's proceed to our examples. So again, we have here our truth table for conditional and biconditional statement. We will base our decision in determining the truth value of a given statement on this table here. There are four possibilities. So for example, we let P as the measure of angle A, which is 102 degrees. And our Q, it is an obtuse angle. So if we are going to translate this statement into conditional statement, so we can say, if the measure of angle A is 102 degrees, then it is an obtuse angle. If we are going to analyze, when we determine the truth value of this statement, our P, which is the measure of angle A, is 102 degrees, and our Q, it is an obtuse angle. Now, if we will assume that the measure of angle A is really 102 degrees, then our second statement, which is an obtuse angle, is a true statement, because the definition of an obtuse angle are angles that measures greater than 90 degrees. In this case, since this is 102 degrees, therefore, the truth value of this statement is a true statement. Since our P is true and our Q is true, so therefore, the compound statement P implies Q is a true statement. This is the compound statement. Now let's proceed to another example. We let P, I can play basketball, and we let Q, I can play tennis. So if I have to translate this statement into a biconditional statement, of course, using the connector if and only if. So this statement can be written as, I can play basketball if and only if I can play tennis. So if both of these statements are true, then the whole compound statement for biconditional is false. But if either of these two statements are true, then the whole compound statement is true. If I would assume that I can play basketball and I can play tennis, therefore the whole statement is false. But if I would assume that I can play basketball but I cannot play tennis, therefore the whole statement is true. Let's proceed to another example. For example, we are given these truth values for the different variables. Our P is false, our Q is true, our R is false, and our S is true. And we determine the truth value of the following statements. So we are given not P or R implies not Q. As you have observed, we have here the or because we already have discussed the proposition in our previous video. So this is our statement. Write the equivalent truth value for each variable. So since our P is false, so we can write, we copy the negation here, then our P is false according to the given. Our R is also false, we copy the or, we copy the symbol implication, then we copy the negation. Our Q is true, so we write there T as true. We will get the negation of this statement, not F and not true. So the negation of not false is of course true. We copy or false. Then we copy the implication. Then not true, of course, is false. Then true or false, according to the truth table for disjunction, true or false is true. Now, true implies false. That falls under the second row, which is true implies false is false. So therefore, the whole statement is false. So the truth value for this statement is false. Next example. P and Q implies not R and S. Again, we change the truth value for each variable. Our P is false, our Q is true, our R is false, our S is true. Since this is AND, false and true is false. We copy the implication, then we have the not. The same, false and true is false. But because of this symbol negation, so we can write this one as, since the negation of false is true, we copy the false. So this becomes false implies true, which is under the third row. False implies true, the whole statement must be true. So the truth value for this statement is true. Let's proceed to our next example. The same, we are given P is false, Q is true, R is false, and S is true. We determine the truth value of the following statements. We have R implies P, which is this truth table, if and only if not S. So we change the variables with the equivalent truth value. Our R is false, our P is false, our S is true. Then if implies if, that means under this row, false implies false is true. So that's why we have true. Then we copy biconditional symbol. Then the negation of not true is of course false. So true if and only if false, that falls under this row. True and false, therefore this is a true statement. Now for the last example, we have P or not Q implies S if and only if R. So we change this variable by the truth value. So we have P is false, Q is true, S is true, R is false. Then we get the negation of true, we copy F. The negation of true is false. We copy the remaining statements. Then we have false or false is false. This one, false or false, according to disjunction, we have false or false is false. Implies true if and only if false. So that falls under the second row. True and false for biconditional statement is true. So therefore this is true. Then we have false implies true. False implies true is true. So this is a true statement. Okay, so that's it. I hope you have learned something from this video. If you have questions, just write in the comment section. And please do not forget to subscribe, like, and share to your friends, especially those who are incoming grade 11 students. So thank you and God bless.